Okay, these are a few ideas on slope fields. I'll just mention this. Most of it, we've been through this, and you can pretty much read the section. I'm going to put a couple of videos in here that are just from our review, from our practice test that show constructing a slope field, similar to your homework problems number 29 through 34, so you can take a look at those. The other ones are kind of multiple choice, so you can get an idea. I think that'll be pretty easy. But first of all, let's take a look at just the idea of what a slope field is. It's just all the solutions, all the possible, as many possible solutions as we can notate of a differential equation. In other words, if this is the differential equation, dy dx equals the cosine of x, what would the solution be? Well, we know it'd be the antiderivative of the cosine is the sine of x, so it'd be the sine of x plus some constant. But we don't know what that constant is, so there's lots of possible solutions. That's where we get a field of slopes, because this is a whole family of curves, and this describes a slope. So let's take a look at how we could graph that, and I'll show you a way to do this. Now, some calculators have a differential equation mode, so they can actually graph slope fields. Our TI-83s don't, but we can kind of get a good idea anyway of what a slope field would look like. So let's start. And I'm going to try some values. Now we're going to do cosine. We're going to try some values of c, and I'll just try with integer values. We could do a lot of them, but we don't really need to get the gist of what's going on, so hopefully you can see everything here. Let me get this up just a little bit so you can see more of the calculator. There we go. Okay. So what I'll do is I'll go to my home screen first, and I'll put brackets. So second parentheses, and I have a bracket. And I'm going to put like -3, comma, -2, comma, -1, comma, 0, comma, 1, comma, 2, comma, and 3, and then I'll put second bracket. So that's what we've got. Hopefully you can see that all right. Move this down. This is what it's going to look like on the screen. Okay. And that's how I put it in using the brackets, okay? All right, then we're going to graph this. Now remember, our solution was the sine of x. So we're going to go back. And we're going to go to y1, we'll put sine of x. Okay, and then I'm also going to put plus, and I'm going to put, oops, go back. Excuse me. I forgot that I'm going to got to store this. So I'm going to store this, pardon me, I'm going to store this, and I'm going to store this in L1. That's for a list, L1. So that's what these L's are for lists. So I'm going to put second 1. So that's going to be stored in L1, pardon me. Forgot that minor detail, okay? So we'll have this, again, bracket, these numbers, store L1, we know how to store, okay? And then if you press enter, you'll see you'll get that when you get that. Now we go back to y1, and I've got sine of x, and now I'm going to put plus L1. So second 1, okay? I'm not too sure if I went over this last year. Okay, so anyway, so this is what we've got. Okay, and now I'm going to graph it. I'm going to zoom trig, graph it in trig, and then you see what's going to happen. So what you're going to see is all these family of curves. So you actually get what the slope field looks like. And all these curves are sine of x plus c, and if you take the derivative or the slope of all these, you get the cosine. So this is actually your slope field. Now if you open your book and look over on page 323, what they've done is they've shown how to construct this with little lines and stuff and marks. And they did the cosine, which was pretty easy, because the cosine of x is just in terms of x. So when you're in terms of one variable, it makes it a lot easier to deal with. So I'll kind of refer to that. But anyway, hopefully you can see that you can do this for your slope fields, and it's pretty easy. And you can get a good idea, so you can kind of, as long as it's in terms of x, one variable, it's pretty easy. When it's in terms of two variables, we have to be a little bit more creative and more, kind of work these out in a general idea. They're a little more difficult. But again, this was the cosine, and this is how they constructed the field. And this is a basic one because it only depends on x, so it's easy. And we know when x is 0, what's the cosine of 0? 1. So no matter what the y is, it's always 1. And then over here, this next level, they said, well, when the cosine is going to be, this would be pi, when the cosine is pi, or when x is pi, the cosine of pi is -1, so they've got all these slopes of -1. And also when it's negative pi, it's -1. Okay? And then when they go to the next level, when the cosine is pi over 2, or 3 pi over 2, or minus pi over 2, or minus 3 pi over 2, the slope is 0, because the cosine of pi over 2 is 0, or 3 pi over 2 is 0, so they put all these zeros in. So this is kind of an easy one to graph. But then also, if we looked at what we've got, and it goes through here, this actually looks like it's the sine curve. Okay, so what we got with the calculator was very similar to that. Okay? So that's a little bit about slope fields, and we'll talk about Eulers in a second. And then, like I said, I'll have a couple of other examples. They'll be in the folder, and take a look at those, and those will actually give you, I think it's problem 8 and problem 15 from our practice test, and that actually gives you an example of doing some slope fields like your homework problems, and also one of Euler's, an Euler's problem. But I'll go over Eulers in just a moment.